It's an honor to introduce Professor Schuett. Professor Holger Schuett combines academics, research, and professional services in the field of port and terminal processes and IT. He grew up in Germany and received his diploma in applied mathematics at the University of Hamburg. After he obtained his PhD in autonomous technology in the Technical University in Hamburg, he joined HHLA, the biggest terminal operator in Germany. In HHLA's IT department, he has responsible for the field of simulation and emulation for container terminals processes. The major project was the simulation-based support for the fully automated terminal in Hamburg Altenwörde, CTA. The emulation systems developed in 1999 to 2002 are still used for software releases as well as optimizing terminal strategies. After CTA's going live, he joined 2003 the worldwide recognized Institute of Shipping, Economics and Logistics, ISL. In 2010, he founded the commercial subsidiary ISL Applications GmbH, today known as Akquinet Port Consulting GmbH. Also, in 2010, he joined the University of Applied Sciences, Bremerhaven, as a professor for the master course, Integrated Safety and Security Management. In this position, his main area are the maritime logistics, including port and terminal operation and mathematical methods. We welcome you, and over to you, Professor Schuett.
Okay, you see my screen, I hope.
Yes, Professor Hu.
Okay. Yes, thank you very much for this introduction. Dear participants from ICLSE2021, a warm welcome from Germany. Unfortunately, I'm not able to meet you in person, but I'm very honored to be invited for this keynote speech in the workshop Digitalization of Container Ports. And that's where I'm working since 30 years now. I'd like to thank the organizers, especially Dr. Azela Kulatunga, for this invitation. And if I look at this panel today, I'm really impressed by the list of experts with whom I may discuss this topic. Congratulations to the organizers. Okay, so my speech will be about the digital twin. Hans-Dietrich Hases already suggested I would do it, would talk about this topic. Yes, that's where I'm working since many years now. Oops. After a short introduction, I will also give a short overview about digitalization in ports. And then we'll come to the digital twin for terminals. And we'll give you an overview because why I feel it should be based on industry standards. And I will end with some conclusions. So for the introduction, you already mentioned I am mathematician and did my PhD in automation. After that, I went to HHLA, and this is the terminal. This was the second fully automated terminal in the world after ECT in Rotterdam, which started in the early 90s. Altenwörde went live in 2002, so nearly 20 years ago. And as mentioned, I was responsible for the whole simulation and emulation work until it started, and the tools are still in operation now to support the day-to-day operation. With the Institute of Shipping Economics and Logistics, I am also working in the field of simulation, not only for the terminals, but also for ports. And the ISL is not institute or at a university, it's a private foundation. And the main idea, and you heard it from Hans-Dietrich Hases, who was director of this institute, that main idea is not to do the base research, but to look at the research done in the world and try to transfer it to the industry. So at the university, I did some lessons already in 2003 when I went to ISL about IT projects, software engineering, stochastics, and seaport and terminals. And since 2010, I'm got this professorship in the master course, Integrated Safety and Security Management. And my main fields are maritime logistics and mathematical methods and mathematics itself. And now I'm managing director. Besides these both other jobs, I'm still at the university and at ISL. I'm also general manager at the akquinet Port Consulting, a company which was founded in 2010 as a subsidiary of the institute to provide these simulation services, but also the products that may be used by the end user, yes, worldwide. Besides me, there is on the one hand side, Norbert Klettner, the other managing director, and our ChessCon hobby horse, like we call it. It's, yes, the family of simulation and emulation products that we provide to the market. As mentioned, we are looking for ports and terminals. We are supporting the stakeholders there from the first idea over the procurement process with the tender management and the whole implementation phase of the IT systems and the equipment until terminal startup, and of course optimizing the day-to-day operation. And if you look at the topics that are mentioned, this is everything, really everything about IT and processes on the terminals. And one, yes, quite curious example here, everything about IT, really. Yes, you see here a container on the upper left. This is a data center. So at the port of Lomé, they wanted to start the terminal. The equipment was there. The port was ready to start, but the office building was not ready with the data center that they wanted to build. So we provided really a toss in a box, let's say, terminal operating system really in a container to start the operation at the terminal. And this data center is still running as a backup system on this terminal. So really believe everything about IT and terminal, IT and processes in the terminals. Next one will be about the digitalization. And yes, Hans-Dietrich also already mentioned the demands for the ports and for the terminals are becoming bigger and bigger. On the one hand side, we have still increasing international transportation on sea, as you see here from the statistics. This is a statistic from ISL. What is it showing? It's showing the increase or the worldwide throughput of containers. And you see two lines. First line is blue. This is the number which is originally reported by the ports at the end of each month. They are sending us this data. And the red line is calculated by my colleagues who are taking out the seasonal impacts. And one seasonal impact, you see it each February. And this is caused on the one hand side because February has 2 days less than the other months. But the second impact really is Chinese New Year, which has such a big impact on the container throughput of the whole world. So what we see here is it's still increasing. It's not increasing as fast as in the 90s, where we had 9 to 10% each year increase, but now it's about 3 to 5% per year. And you see here this valley caused by the COVID situation, by the pandemic situation. But you see, we are already at the end of 2020, we've been above the numbers that we had before. So it's still increasing. And on the other side, the vessel sizes are becoming bigger and bigger. And what does it mean for a port? If you want to have the same throughput with bigger vessels, typically these bigger vessels are bringing bigger package sizes, more containers to be discharged and loaded. And this means you have bigger peaks in the ports and especially in the terminals. The bigger vessels with the bigger package sizes, they are coming to your terminal. And yes, you have to discharge and load this vessel, and you won't get much more time than before. So you have to increase your productivity. And one way to do it is digitalization, as Hans-Dietrich mentioned. But is this really a new technology? Nowadays, people are talking digitalization since, let's say, 4 to 5 years. It's really a buzzword in the industry. But is it new? I think more or less it's an ongoing process. Let's have a look at the yard planning. So when I started my career at HHLA in the 90s, we had these boards, big boards at the wall, and each card in this wall, on this board, is a container, and it's shown where it is stacked in the yard. So this, I really saw these boards when I started at HHLA. This is analog. And then, of course, more and more computers came in, and the first data was typed into computers. I was at that time working with the IT department of HHLA and was responsible for develop these programs to first collect the data and then also to use the data. And if this, as mentioned, was 30 years ago, and the amount of data, of course, has been increased a lot. And the main question is not collecting data. This is digitization. But digitalization means to use this data. And how to use this data? Let's have a look at the yard planning. This data is stored in big data centers, not only in containers. We also do provide data centers for the northern German counties, where they have all the administration on. And how to visualize this big amount of data that is available in these computers to the end user, to the planner. These are typical pictures from TOS systems, terminal operating systems. Yes, you see the vessels, you see the containers on the vessels, where they are, and you have a lot of lists and numbers and figures. Another way to show it this way. But what about something like this? I really believe man is a visual, is thinking in pictures, not in tables and not in bits and bytes. Let's do this, the computer. You have to build an interface for the end user. These are the big dashboards which are used by the management. And for the yard planner, we are in this example of yard planners, for the yard planner, this helps. Yes, as if he looks out of the window, he can go into the whole terminal, and he can use it for his planning tasks. And to show you how this works, we have a presentation. I took out very short part of it by Alexander Heinemann, a yard planner here in Bremerhaven, who is using on the one hand side, and this is what you see here, the Navis system and 3.7, with a bird's view on the terminal. But yes, listen what he is talking about. I hope the sound will be fine for you. Otherwise, please tell me.
Still with the new task, we are now switched to Navis in the last year. In May of 2020, we switched to Navis, and we are still using the Chestron system because the benefit of the Chestron system is still a major point also in the work with Navis. Yeah, the overview you can achieve with the Chestron system is much better than the overview you got with the built-in tools with Navis. Yeah. I presented or I prepared short simulation. This is a live view of our yard. It's not the actual one. It's maybe a few weeks old, but it's quite realistic. And that's the view our yard planners are working daily with it. Most of the time, we use the Chestron system is if we have to select containers. So if you got a load-out order for empty containers or got delivery order for empty containers, the Chestron tool is a major tool to find the containers the very fast way all over the terminal. To demonstrate that, I prepared an easy filter. And you can see all the containers in the yard are still visible as gray containers, and only the units matching the filter are highlighted with a color you can select by yourself in the filter. So it's not even possible to have one color. You also can have multiple filter criteria with different colors. So if you, this is a full 3D view. You can zoom in the yard, you can out, you can turn the view, not that good, to find the right angle to see the units you selected in the yard. Yeah, for example, this unit, to see it's a live system, you can click on the unit, open the filter, and see the selection table, and you have all the attributes of this special unit you selected in the yard. So all of the boxes in the yard are visible, and all the information for every single unit is available in the system, and you can have an overview of all the information you need.
Okay, so this was a yard planner. It's I like if people who are working with the systems are talking about it, how they use it, why they use it, etc. So this is a Hamburg terminal. You see it like you fly with a drone over this terminal. You get a picture or a view like this. But additionally, as Alex mentioned, you can have some filters. Who are the boxes? Where are the boxes for the next vessel? How many restowers will occur? What about the hazardous deck? And so on. And in this case, I just looking at the weight of the containers. So the darker the containers are, the more heavier they are. And you see here near the export berth, where the big vessels are berthing, going to Asia, you see the heavy containers are. Why is this? This is because Germany as an export country, or even Europe with the export, we are exporting a lot of machines, a lot of components of heavyweight products. And therefore, you can see it here. And this is what I mean with people are understanding pictures better than tables or bits and bytes. Now you see, you get an information about the type of export by just looking at the picture, by seeing the heaviest containers are near the export berth. So this is a synonym, you know. I think a picture shows more than 1,000 words. And I would add, it is more intuitive for people than 100 tables. So the next step in using this big data is really the digital twin. And Hans-Dietrich already mentioned it, and I liked his definition. I will give you the definition soon as well. So in the 90s, we already built models of container terminals. This was for the terminal planning and design, mainly. It's not us as a company. I mean the research world is doing this. They started in the 90s to look at simulation for container terminals. And if you look at the lifetime, we already saw it before. We have the pre-planning phase, the design phase, the first idea. You want to show somebody your idea. There is a planning phase where you think about the operation system on your terminal, where you compare different systems, compare different layouts. You have to think about the number of equipment required for planned throughput and so on. And this is done by tools like this one. Here we are looking at the capacity of the terminal. We are mainly looking at the seaside. So various types of vessels are arriving. They have, some of them perhaps have to wait because they are not able to be served at the moment. And then you see there are key cranes working on these vessels. We don't see any transportation on the yard, but we see the utilization of the yard. So you can calculate how much slots do you need. In this case, you see the reefers that you planned are too less. The reefer slots that you planned were too less. So you need more of this. A very short example. And then, yes, this was in the last century. In this century, as I mentioned with the Altenwerder terminal, we use this simulation not only for planning the layout, but for startup and operation. So we call this the tactical planning phase. And the main idea is you use the simulation models for the transportation of containers, for the whole material flow, but the decisions are made by the real TOS. So you connect the simulation model to the real system. And in this case, you have what we call a virtual terminal. Yes, you have the real terminal, you have the virtual one. You use the real software interfaces from the terminal operating system, and thus you have a wonderful test bed. Yes, you can test your TOS before you're going live. So typical, without emulation technology, you do a demand analysis, a system design, then you develop your TOS or configure your TOS. And if when the equipment comes on, then you test the TOS together with the equipment. But what about doing it with a simulation model? It's faster because parallel to developing configuring the TOS, you build the model and you can start testing the TOS earlier. During the configuration process, you can already start to test your configuration. You still will have an on-site test because you have to test whether the equipment is also running and the interfaces are correct from equipment side, but it's shorter. And this means you save time, which means you earn money. And this technology may be used all over the whole lifetime of the terminal. This is what I mentioned with Altenwerder. So I think 2-3 years ago, they looked at the dual cycle, not only at the key crane, but also dual cycle in the transportation with the AGVs. And during a conference I meant like this one, I mentioned air, and this they tested it 3 months before they went live. they tested this against the virtual terminal. And then somebody rose his hand. This was a conference in person. Somebody rose his hand and said, Holger, you're not right. I said, oh, what's happened now? He said, we tried it after 3 months. But when we did the tests, we felt it's not good enough. Our strategies are not good enough. And we didn't implement it after 3 months, but we tested it for another 2 months and then implemented the optimized solution. So this is how it works. You see on the lower side here, a terminal operating system. It's the old one from Navis, the Spark 3.7. And above you see the transportation, you see the virtual terminal model, the simulation model. And any time a container is dropped on a truck like here, the status on the lower left is changing to carrying container to waiting, to row. And now he is doing the job that the TOS decided. So the TOS decided where to bring this container, and the truck is just doing the work like the truck on the real terminal. And this is a wonderful test bed for TOS and helps people. And we are not only working for the industry, we are also doing research projects. One example here with a Korean partner, Total SoftBank from Busan. We tested and developed some new rule-based yard and equipment strategies. This was with the University of Bremen. This was with Hans-Dietrich Hases together. And it was successfully finished this year. So, but what's next? I wanted to talk about digital twins. So we do have a test bed. We have a connection between the TOS and the simulation model. But we are not using the big data that is available already. And if we look at the digital twin, some people call a digital representation of a real-world entity or system, let's say a model, like we did it in the 90s already, they call it already a digital twin. But I like more the definition that also Hans-Dietrich mentioned. It was developed by Dr. Michael Greaves and John Vickers in the US. And they said, okay, for a digital twin, you need 3 parts. The real system, of course, I would say. The virtual product, that's the simulation model of your terminal. And I think this is very important. You need the connection between these both products, between the real world and the virtual world. So in this case, the virtual world is at each piece of time or moment of the time in the time. It's any moment it's on the same state as the real world. And this is something that not only we are thinking about, but also at the talk Asia last year, last year, in April, this was here, Tang Chongmeng, the group CEO at PSA International. He mentioned that digital twin technology is one of the most important areas of investment for terminal operators. And he said terminal operators should start with digital twins as it allows ports to use data to understand and measure its processes and outputs. And what is the difference between this emulation, what we call the virtual terminal, and the digital twin? We do again have a virtual environment. We have the real environment. The real environment is connected to the terminal operating system, and we are just listening. Each pickup, drop off, state change of an equipment, whatever, everything is sent to this virtual model so that the virtual model is at any time on the same state as the real world. And this is how it looks like. So this is a terminal in South Africa, the Durban terminal with this famous Z shape. And you see there are a lot of straddle carriers in this case operating on this terminal. So discharging or transporting the discharge and loading containers on the yard. And similar to what Alex showed in the yard view, this model here has real data in it. So in the digital twin, it's directly connected. Yes, and if you click on a container, you will get all the information about this container. And all information really means each single attribute of the container, which is in the TOS system, is shown here, is part of this. And you can then not only show it, that's fine, but mainly you can filter again. And let's have a look at the containers which will be loaded to the vessel that we see here on this berth, served by 4 cranes. Yes. We just say, okay, show me all containers with this voyage number. And you see, they are shown here. And it's quite a good yard planning because most of the containers are near the yard and near the berth. But there are some containers here on the left-hand side or the lower side, which are not directly at the area. So if you have time, just do some housekeeping moves. And of course, you can do the same with each single piece of equipment. It's not only with the containers. You can look at each single piece of equipment. Let's have the threads here. We select one of the threads. I think it's the one in the row here in the middle, in the lower middle. Yes, you see a big arrow upon it. And you see what is the current productivity. What is he doing? He's picking up a container. Yes, we see it. And after he picked it up, now it changes to transporting. And the same you can do with the key crane and with each single piece of equipment. On the one hand side, what we are doing here in this project is just looking at the productivities. And again, also with the equipment, you may color the equipment by the productivity. So if a key crane, these are the original colors at the terminal, but you can also show the key cranes green if they have a high productivity, yellow if it's okay, but not that good, and red if they are under productivity. This is additional information to just the real world. Yes, you can show more. So the difference, don't want to go too deep into this here. Simulation used for the strategic planning. The level of detail is low to medium, but the speed is very high. In the emulation, the speed is low because you have to couple it to the TOS, and typically a TOS is not able to run faster than, let's say, 5 times real time to serve the to serve the messages between the real system and the TOS, because it's defined or it's developed to run in real time. So therefore, it's a very high level of detail because each single decision is directly made by the TOS and the transportation is done by the simulation model, but its speed is lower. And with a digital twin, you have a combination. You use it for the operational simulation. The connection to the TOS is only reading the current state. It's all the time it's updated. And then the decisions are made by a system which is very similar to the real TOS system using the same TOS parameters. So the expert tagging strategy, pooling parameters, etc. And how to build this digital twin? You would say, oh, this is wonderful, but it will take a lot of time to build a model. Yes, you have to build a model. Think about it. Draw each block, each slot of the terminal, whatever. And there we say, okay, you may also have, not now, but within the next years, we will have semi-automated digital twin creations. And for this, we are working together in some initiatives. We are working together with the Singapore-based PortML initiative. They want to define a standardization for a layout of a container terminal. So how to find a standardized definition of a container block, of a container row, of a container slot, of equipment, of traffic network. Yeah. This will be done within this initiative. Then we have a layout. The layout is half the word, half the work. Next, what we need is data. What is this scenario? What types of vessels are arriving? What is the container mix? What's the typical package size the vessel brings with him, and so on, all this data. And here we have a cooperation with APMT. They do have what they call asset digitization. This is their big data lake. All the information from their terminals, they have in this big lake, and they know which types of vessels are arriving. They know each single move that had been done. And we are connecting this to our simulation models to import the relevant data from this database. Also very, innovative project that we finished at the beginning of this year, together with APMT, with the headquarter of APMT. And then for the digital twin, you need the current state of each piece of equipment. And for that, we are using the live data connected by another initiative. This should be very interesting for you as well. It's the TIC 4.0 Terminal Industry Committee. And they, again, standardize the messages between equipment and the TOS, between subsystems, equipment control systems and the TOS, and so on. But when they started, they first found out that we have to define the KPIs first. What is moves per hour at a key crane? What is a move? Yes, and they defined, you may look at this site here, www.tic40.org, and you will find a definition template of these KPIs. So if we do this, if we have a standardized definition of a layout, standardized messages, and we get scenario data out of the big data from a terminal operator, then we can really semi-automated create a digital twin model. So what to do with a digital twin? First idea is quite easy. You have a, if you run a terminal, if you do a simulation, first you have to calibrate your model. You have to show that the model is behaving like the real terminal. But this may change. Yeah? If you have a training for your crane drivers and they are more productive, then you have to change the simulation model by calibrating it again. And this can be done automatically if it's connected directly to the real world. I can react on exceptions, because in this digital twin, we do have also a simulation component, which is able to run a fast simulation for the next hours. Yes, and if a crane breakdown is there, you have to reschedule. Hans-Dietrich has mentioned in 10, 20 years, this will be done, everything will be done automatically, but today the planners have to reschedule the whole work on the vessel. And then you can run fast simulations to check whether it's a good plan that you made. And you can automatically check the current plan. If you are at the same state as the real world, why not running an automated simulation each hour, each half hour, each 10 minutes, whatever, to see whether you will finish this vessel in time. As you may know, in Germany, we have some restrictions with the tide, so tidal restrictions, when vessels are allowed to enter the port and leave the port. And therefore, it's very important to see whether you finish it on time. If it's 1 hour later, you may have to wait another 12 hours to leave the port again. Yes, conclusions. Digital twins of container terminals should be built by using emulation model of a terminal, should be connected to the real terminal by only listening to the TOS and equipment's messages. They should use a fast preview module to predict the future behavior, and of course should use industry standards, so then it's easier and faster to build it. They combine, on the one hand side, the detailed behavior of the emulators. They have the current state of the terminal and this fast simulation model of the preview module. And this may be used for improving the operational planning and to secure the operational planning. So what happens next? At the moment, we are working together with Busan Port Authority on a twin prototype for the terminal. It's developed yet and will be tested until end of next year. We have very interesting research project together with the Hamburg terminal, where we use the digital twin also for predictive maintenance. They do have a lot of sensors on their equipment, and together with AI-based evaluations of current and historical data, you may find some patterns which will lead to a breakdown of the equipment. And if you find this pattern before it breaks down, you can do predictive maintenance, not doing maintenance because another 3 months are gone, but really looking whether it's necessary after 2 months or perhaps after 4 or 5 months. And of course, process optimization supported by the fast simulation module. We're working on a digital twin as a live view together with a PDS supplier. And what I'm very interested in is what will be next in Sri Lanka? What are you planning to do with digitization? And that's why I'm very happy not only to give this keynote, but also to hear your views on this topic. I'm looking forward to hearing from you soon, or to get your information within the next 2 hours. Thank you.
Thank you very much, Dr. Holger. In fact, that was a very impressive presentation. Of course, like we've been seeing digital twins of probably small equipment and so on in the manufacturing environment, but you talking about digitalized port of that massive scale, it's very impressive. Dr. Holger, I'm very sure there will be a lot of questions and comments during the entire workshop, but immediately after Professor Holger's presentation. If there is any urgent questions within the audience, we have a few minutes time. Okay, until we get some questions, Professor Holger, I'll just raise a question. Well, of course, being in the manufacturing environment, we've been thinking of some kind of digitalization of how product moves and all that. But in terms of port digitalization, I guess environmental factors can also play a major role. So, to what extent have you really been able to capture the environmental aspects into this digital twin? Has it been considered, and to what extent that's been accommodated?
Yeah, of course, we will also have a look at that, because with the terminal that we are working, most of the machines are diesel driven. So we also will have a look at how to not only optimize the operation, but also, yes, save fuel, save energy. And this is something, this will be part of the emulator of the piece of equipment. Also, the fuel or the energy consumption will be calculated and maybe forecasted and compared in different alternative scenarios. Yes.
Okay, thank you, Professor. In fact, what I originally meant to ask was this environmental aspect, such as, say, like probably the winds and gusts, or probably the sea waves, that such variations, will this model be able to capture those aspects as well?
The sea waves and so on. And we are mainly at on the terminal itself, yes. So in this case, what we are doing is, what we are also looking at the terminal, because here in Bremerhaven at the terminal, we have problems from time to time with high winds. So we will also have a look at that, what is forecasted for the next hours, and will this include into the simulations, because then the productivity may go down a little bit and so on. This is something we will, on the one hand side, evaluate with the AI, artificial intelligence methods, to see, to compare what's the productivity by different weather conditions.
Thank you very much, Professor.
Yes.
Yeah. Are there any other questions from the audience? Professor, there is a kind of a request in the chat. I can see asking and appreciating if you can share the presentation.
Yes, of course, we can do this. Or you can do it, I don't know. Yes, we should share it as a PDF, yes?
Yeah, we will.
Because with the videos, it's we have a German very hard clauses or regulations about individual data and so on. So Alex Heinemann speaking in a video is, I'm allowed to show it here, but I'm not allowed to upload or download it directly.
Yeah, thank you, Professor. Yeah, well received. Well, there is one other question in the question, if you might see. What are the initial challenges when implementing the digital twin? Probably if we can word it, probably what was the largest, or the biggest challenge when you were into the digitalization?
At the moment, it's still because we don't have this the standardization in all these fields that I showed. This is why I mentioned we have to use standardization for the interfaces. At the moment, we have to connect to each single TOS system. We have to connect or build interfaces to the TOS systems. We have to build interfaces to the data lakes of the terminal operators. We have to build interfaces here and there. And this may take time. So in our case, we have a SDK, so that terminal operators or TOS suppliers may take over this work. This we did with an Indian company, with Tata Consulting Services. They built the interface between their control system and our systems by themselves, based on, it's not a standard yet. We have to use the standards, and then it's will be very easy. I think we are prepared with on our side to directly import layouts from some TOS systems and so on. So it's let's say quite easy to build it, but having the interfaces, especially to the different equipment providers and so on, this, as long as they are not using standards like the TIC 4.0, there will be individual development required.
Okay, very interesting. Professor Holger, I think we have, and we should take this question, probably the last question coming from Mr. Jayanta Pereira. Probably it is connected with the first question I raised. The most challenging issue in modern time in Sri Lanka ports is the unpredictable weather. The visibility is the key factor disturbing the operation during rain, wind, and fog. We prefer to set up a statistical condition where a computer can decide what visibility levels to consider and at which statistical point we should stop operation or resume operations. Are there such technologies?
Yeah, this is what I just mentioned with this research project that we are doing. We are working together with the university there as well, with the terminal operator and with the university. And I think in this case, it's a university in Hamburg. And they are, working especially on analyzing historical data to understand the interface, the interaction between weather conditions on the one hand side and productivity on the other side. So we will not give the weather forecast, but we may see, based on current data, current weather data, whether this may lead to some disturbances on the terminal or not. And this is part of the project.
Okay, thank you very much, Professor Holger. Of course, we are getting few more questions, but I guess that during the panel discussion, there will be more exciting.
Yes, I will be there.
Yeah. So we may leave some of the questions for the panel discussion. So with that, I would thank you again, Professor Holger, for that very insightful talk. And then looking forward to continue the workshop with your presence. Thank you very much, Professor Holger. With that, and participants for raising important questions. With that, I'll conclude this keynote, and I'm handing this over to Smriti.
Thank you, Dr. Prasanna, and thank you very much, Professor Schuett, for that intriguing presentation. Now, the coordinator of the workshop, Mr. Namal Bandaranaike, will take over the proceedings after a message from our sponsors.
Managing container terminals is challenging, and it becomes more and more complex with the wide range of challenges. You want to automate processes, but need to stay flexible. Digitalisation is key, but how can this transformation be managed, and how can we accelerate it? Labour and equipment costs must be kept under control. And what about terminal operations? Can they continue despite their CO2 emission? Decision